Alright, this video is not going to be quite as good as some of the others because I realized I was missing this one. So I'm going to run through some stuff really quick for you, and hopefully it'll be enough that you can work your way through it. Now, in your notes on lesson 6, it starts off with talking about why we're doing what we're doing. So we're trying to predict a redox reaction. This is going to feel really similar to what we did in the last lesson, in the last unit when we were trying to predict acid-base reactions. So the first thing you need to know is it's going to be very similar. And sometimes like it says in your notes, sometimes you will not be given the reaction that's taking place, you'll just be told what's combined, kind of like in the last unit. So just like in acid bases where we had the strongest acid and the strongest base reacting, in this we're going to have the strongest oxidizing agent and the strongest reducing agent reacting. So step number 1 is we need to list all of the entities present. And just remember that it's just like in the acid-base unit. If this is a solution, then you need to dissociate anything that's ionic. If it's a strong acid, we're going to split it apart. The only difference is it's a little bit simpler. We're just going to use Arrhenius's theory, so just H positive instead of H3O positive. And then if it's a solution, remember to put water. So let's work through this example. We'll just go through a step at a time, and hopefully this makes sense. So we have tin 2 chloride. So I know it's a solution, so that's going to dissociate into tin 2 ions. Let me just see if this will let me right on here. All right, give me 1 second. Okay, so let's try this. So we've got tin 2, so I've got tin 2 positive, chloride, so Cl negative, and it's a solution, so I know I've got water. Now, then I move on to the next thing. I've got acidic potassium permanganate. Now, because they said acidic, I know that there's going to be some H positives. And then I have potassium permanganate, which is potassium ions, K positive, and permanganate is MnO4 negative. And they say solution, but I've already written water, so I don't necessarily have to write water again in this case. So now I've listed everything out. The second step is I need to identify who's the strongest oxidizing agent and who's the strongest reducing agent. So the last lesson we were working on...
Hi. How you doing?
Sorry about that. The nurse just came in for some vitals. Okay. So in order to tell out of these who's the strongest, we need a list. Remember in acid base we had a table in our data booklet. In Redox we have the tables that we've been building the last couple of days. But thankfully for you, you have one in your data booklet. So take out your data booklets and go to page 7. On this page, you'll see up the top it says Table of Selected Standard Electrode Potentials. And then underneath that it has the reduction half reactions. This is exactly the same kind of table that we've been building. So everything on the left is an OA, and you should probably even label that on your data booklet. Just put OA on the left. And everything on the right of the reaction arrows is the RAs. And you could do the same thing on the right. Remember, the OAs get stronger going up the chart. So in this case, the strongest OA on this chart would be fluorine. And the RAs on the other side get stronger going down. So the strongest reducing agent would be lithium. So the trick now is you've got to go through that table and find everything on there and find out who's the strongest. So I'll give you a little hint. Tin 2 is on twice. Remember that some things were in the acid-base unit on both sides. Tin 2 is one of those in this unit. So is water. So while you're looking, I'll give you a second, maybe pause the video and give everybody a chance to look. See if you can find out of that list who's the strongest oxidizing agent, who's the strongest reducing agent. Okay, hopefully you found that the strongest oxidizing agent is the KMNO4, or the permanganate, the MnO4 negative. But you'll notice in its half reaction, if you're looking on the table, if you didn't find it, it's the third one down from the top. But you'll notice the reaction is MnO4 negative plus 8H positive. So I can only use that because I have both of those pieces. So since they're both there, that's my SOA. Okay. Then you look at everything else. On the right side, the lowest on the right side I have is tin 2 as my SRA. Okay. Now we need to write those two half reactions. So for the SOA, I go to the data booklet and I'm going to copy it straight out. I have MnO4 negative plus 8H positives plus 5 electrons becomes Mn2 positive plus 4 water. Okay, and that's all you have to do. Just straight out of the data booklet, don't change anything, just do it just like that. For the SRA, though, it's not being reduced, and this table is everything being reduced. So because the RA is being oxidized, I have to find that tin 2 reaction, and I have to write it backwards. So that's tin 2 positive. So the tin 2 in this case, in this reaction, if we work backwards, if you couldn't find it, by the way, it's at the positive 0.15 if you look at the numbers on the right. So in this case, the tin 2 is becoming, as we go backwards, tin 4 positive, and to do that I had to lose 2 electrons. Okay. Now very similar to the lesson where I was showing you how to complete a reaction, now we have 2 half reactions that we have to combine. So in order to do that, we have to balance our electrons. So I have a gain of 5 and a loss of 2. The only way to make those work is if I multiply this reaction by 2, so now I'm gaining 10, and I multiply this reaction by 5. If I do that, I'll be gaining 10 and losing 10, so I can cancel those electrons out completely. Once I've done that, I can write the net equation by combining everything that's left. So now I have 2 MnO4 negatives, I have 8H positives, oh sorry, not 8, I forgot the double, 16H positives, I have 5 SN2 positives, and on the other side 2 Mn2 positive, 8 water, and 5 SN4 positive. Now, when you finish this, double check just to make sure you don't have anything that you can cancel. In this case, we don't. There isn't anything that's on one side that's also on the other. But if you did have some, you may have to cancel some waters or some H positives, or the most common that you would have to deal with. So this gives me my net reaction. The last part is just indicate if the reaction is spontaneous or non-spontaneous. So just like we did from the last lesson, you'd look on your table. Is the OA, in this case the permanganate with acid, above the RA, tin 2, which it is in this case. So all you'd have to do is write over the arrow either an S or a spontaneous, or however you want to show that. Or you could write it to the side of the equation, but you do need to recognize and mark down somewhere that this will be a spontaneous reaction. And that's it. For each question, you're going to go through, pull out all the species that are present, then you're going to write out the half reactions, balance the electrons, give me the net reaction, and then indicate if it's spontaneous or non-spontaneous. And that's it. So good luck. If you have any problems or questions, let me know.